All right, so this is section 5.3 of Math 146. Now we're going to be talking about the law of cosines. In 5.2, we discussed the law of sines and how that works to be able to solve a triangle, meaning find the missing parts of the triangle. We're going to continue that idea with this thing called the law of cosines, and as you would expect, you're going to use cosine instead of sine. The formula is not quite as easy um, to remember or to manipulate as the law of sines was, um, but you don't end up with any ambiguous cases here, so that's kind of nice. And there's technically three formulas, although it's really the same formula. So I'll write down all three of them, and hopefully you'll be able to figure out why it's really the same formula, um, just written in a different way. But the basic idea behind this one is this is going to be used when one of two cases. You're going to have the case where you've got all three sides that are known. So no angles, but all three sides are known, and we can use that to find the missing angles. And then the other one is if you have two sides and then one angle which is in between, or what's called the included angle. So basically a side angle side kind of thing. All right, so let's get to it. The law of cosines. Again, there are three versions. All of them are really the same thing, and you'll hopefully see what I mean. The law of cosines says that c squared equals a squared plus b squared, which is not the full formula, but hopefully you recognize that as the Pythagorean theorem. There's a little bit more to this, which is minus 2ab cosine of capital C. So that minus 2ab cosine of capital C is the only difference between this and the Pythagorean theorem. And there's a reason for that. We'll get to that as we do the examples. So the other two versions of this are b squared equals a squared plus c squared minus 2ac cosine of capital B. So if you see the pattern, you can probably guess what the other one is. We are going to have a squared on the left, and then, because if you notice the Pythagorean theorem part of this, it would be b squared plus c squared, and then you're taking away 2 times the two angles that are on the right-hand side of the, the two sides that are on the right-hand side of the equation, which is BC, and then the cosine part is the angle opposite of the side that we are solving for. So you can see that these are really all exactly the same equation. It's just solving for a different specific letter. And it really is just about how you orient or how the triangle is presented as to which one you use. But it's really all exactly the same formula. So you can go with any one of them that you want to based upon what is given in the problems. Um, so the proof of this, which I am not going to run through, um, it's pretty interesting proof. It is in the book if you want to take a look at it, and if that kind of stuff makes sense to you, you can go ahead and again take a look at it in the book. I'm going to just jump right into doing some examples, and I think that that'll be enough. This is not going to be an extraordinarily long video. All right, so we're going to start off with an example where we've got two sides and we've got the angle in between those two sides. So we will be asked to solve, which again means to find all the missing pieces, the triangle if A equals 2, B equals 3, and our capital C, which is an angle, equals 60 degrees. So again, you can kind of sketch this if you want to, just to kind of see what it looks like. It does not have to be anything in particular. Your sketch does not have to be super. We'll say that that's angle C for the sake of it, which means that this over here is lowercase c. As a matter of fact, let me change that to a different color, since we know we're solving for that. and we are given sides A and B, which is 2 and 3. So just to make sure that it looks relatively accurate, that would be 2, meaning that this angle over here is A, and that would be 3, meaning that that angle on the top is B. All right, so we're going to go ahead and solve for all of these different pieces. So we can use the law of cosines in this case to find side C first. And if we do that, that is literally the top equation. We are solving for side C, which means that we need a squared, which in this case is 4, plus b squared, which in this case is 9, minus 2 times a times b, so 2 times 2 times 3, times the cosine of the angle in between those, which is 60 degrees. Oops. So we can actually do a good portion of this without the calculator, because the angle was nice. If it's not a nice angle from the unit circle, then it's probably not something we'll do without a calculator. So let's see, that's going to be 13 minus 2 times 2 times 3, which is going to be 4 times 3 is 12. So we get minus 12 cosine of 60, which is 1/2. So then c squared is 13 minus half of 12, which is 6. So c squared is 7, making c the square root of 7. And that is an exact value, which is really nice in this case. That's an exact number. Oops, I'm going to go back and relabel my A and B on the inside of that triangle. You don't really have to, obviously, but I put them in red to make it so that we knew that we were solving for those. Okay, so we have now solved for side C. And now that I have side C, I can use the fact that I have A, B, and C to solve for the other remaining angles. So for example, if I want to solve for angle B, well, that would be this formula right here, because it's the only one that has angle B in the formula. So you can manipulate the formula to solve for B first if you would like to, and that is completely up to you whether you want to do that, or you can just plug all the values in and then solve for B. Personally, that's the way I prefer to do it. I'm going to plug in my A, B, and C values and then solve the expression there when I've got the numbers already in its place. The main thing you want to be careful of is if you're doing it this way, don't round any numbers. Like, we don't have to worry about that here because we solve for C exactly as the square root of 7. But if you're going to use a decimal approximation for that, don't round anything as you go. So let's go with orange now. Why not? Let's solve for B. So we're going to get little b squared, which again is 3. I'm sorry. Yeah. 3 squared equals a squared plus c squared. So a squared is 2 squared. C squared is the square root of 7 squared, minus 2 times a times c. So that's going to be 2 times 2 times the square root of 7 times the cosine of b. And since that's what we're solving for, now we can simplify. 9 equals 4 plus 7 minus 4 root 7 cosine of b. The 4 and the 7 are going to add up to 11, so we'll subtract 11 on both sides, so we get that minus 2 equals negative 4 root 7 cosine of b. And then divide by the negative 4 root 7, so you're going to get 2 over 4 root 7 equals the cosine of b. And technically, yes, you could simplify that, but since we're going to end up using a calculator in this case, because that's not a special value from the unit circle, so we're pretty much going to have to do it this way. Now we're just going to take the inverse cosine of both sides of the equation. So we have the inverse cosine of 2 over 4 root 7 equals b. And when you plug that into your calculator, you get that b is approximately equal to 40.9 degrees. Okay, so now we have everything except for angle A. Certainly you could use this expression right here to solve for angle A. But now that we have two angles within the triangle, we may as well just use the fact that if you add those two angles up, the third one has to be this the remaining angle to add to 180. So instead of doing this the hard way, let's literally just do it that way. And we're going to say that, okay, we know that angle C is 60. We know that angle B is 40.9. And we have to add angle A to get to 180. So that's going to be 100.9 plus angle A equals 180, or subtracting on both sides, angle A is going to equal 79.1 degrees. And we have now solved our triangle, because we have lowercase c, so side C, capital B, which is our angle B, capital A, which is our angle A. And we have solved that right. Just not, you want to keep on saying right triangle. So I said I was going to explain something about how the whole Pythagorean theorem is an important part of this. And that's because if you look at this part right here, on any one of the parts, if you were to take the cosine of a right angle, well, the cosine of a right angle, the cosine of 90 degrees, or the cosine of pi halves, if you do it that way, is 0. Well, that means that whole minus 2ab times the cosine of the right angle goes away. That is 0. So when you have a right triangle, your opposite side, your hypotenuse side, is going to be opposite of the right angle. That's how you would get the Pythagorean theorem. That would be c squared equals a squared plus b squared. Again, that's if c was a right angle. Otherwise, it's going to give you something other than 90 degrees for your angle. So again, if c is a right angle, your capital B, capital A, if any of those are right angles, it forms a right triangle. It would make all the rest of it go away, and you'd just be left with Pythagorean theorem. So really, Pythagorean theorem is just a special case of the law of cosines. Okay, let's go ahead and do one more example. This will actually be the last example that we do. We will do an example where we are given all three sides of the triangle. The only thing you actually have to verify, of course, if it says that you're solving a triangle and they give you all three sides, technically you should verify that you have a triangle. But if they're giving you all three sides, usually that means you have a triangle. How would you verify? I'm going to write down the different sides here. Basically, the two smaller sides have to add up to be greater than the third side. And 4 plus 3 is definitely bigger than 6. So we have a triangle. That's how you would verify. If that doesn't happen, if they're the same or if it's less than, then you don't have a triangle at all. But I don't think that'll end up being the case with any of these. All right, so in this case, we're given all three sides. So pretty much we don't have a choice but to solve for an angle first. Probably the one thing that you want to make sure you do with the fact that we're given all three sides, and again, you don't have to sketch your triangle for this particular one, but I'm just going to sketch a little triangle here to show you what I mean by this. So C is the biggest value, so we'll put the 6 over here, which means that angle C is the opposite one. It's going to be the largest of the angles. And then we can put 4 over here and 3 over here. Doesn't really matter, but we have to write the angles in appropriately. So that has to be C because it's opposite of 6. Angle B has to be opposite of 3. So this is going to be B down here, and then A has to be up there. The idea is you want to solve for the two smaller angles first, because when you end up doing the inverse trig functions, it's probably not going to give you, unless you have a special calculator, it's not going to give you the obtuse angle. It will always give you the acute angle. And you have to know that there's a possibility of the largest angle being obtuse, because it could be the one case where you've got one obtuse angle and two acutes, or it could be all three acutes. But if you solve for the two smaller ones first, which have to be the acute angles in either case, then you can just use that to subtract from 180 to find the third one, and you don't have to worry about the calculator possibly spitting out the wrong angle for this particular problem. So solve the angles for the two smaller sides first. So I'm going to start by solving for angle A in this case. So we'll do, in order to solve for angle A, we would have to use the A squared equals B squared plus C squared formula. So A squared equals B squared plus C squared minus 2 times B times C times the cosine of angle A. Okay, and it's exactly the same type of problem that we did before. So we're going to get 16 equals, let's see, 9 plus 36 is 45, minus 2 times 3 is 6, times another 6 is 36, cosine of A. So we'll subtract 45 on both sides, which should give us, is that negative 29 equals negative 36, cosine of angle A. Divide both sides by negative 36, and you get 29 over 36 equals the cosine of angle A. So we'll have to take the inverse cosine of 29 over 36, which will equal angle A. And plugging that into your calculator, you're going to get 36.3 degrees. So now we have one of our angles. Okay, we need to use it to find the other acute angle, which in this case is B. Now, C could also be acute. We'll have to figure that out, but at least we are guaranteed that the two smaller ones will be A and B. So let's use it to do B. Well, that would be B squared equals, so whatever the angle is, remember that's going to be the same thing as the side that goes on the left-hand part of your equation. So B squared is going to be 3 squared equals, and then it's the other two, so it's 4 squared plus 6 squared minus 2 times those two, which is 4 times 6, and then cosine of the angle we're looking for, which is B. So we get 9 equals, let's see, 16 plus 36 is 52, minus 2 times 4 is 8, times 6 is 48, cosine of B. Subtracting 52 on both sides, we're going to get negative 43 equals negative 48 cosine of B. Dividing both sides by negative 48, 43 over 48 equals cosine of B. And then we will take the inverse cosine of both sides of the equation to get B. And then plugging that in the calculator gives us 26.4 degrees. And we are going to have an obtuse angle, because if I add 36.3 and 26.4, that is well less than 90. So that means the other angle will be bigger than 90 degrees. So in order to finish off this triangle, we will take 36.3, add it to 26.4, and then add that to my missing angle C, and that should add up to 180. So let's see, 36.3 and 26.4 is going to be 62.7 plus C equals 180. So subtracting on both sides, that is going to be, let's see, what is that? 117.3 degrees. Definitely an obtuse angle. And again, you could have ended up getting the first two angles. Both would have to be acute, but they might add up to more than 90, which means the third one would have added up, would have been less than a 90-degree angle, so they would have all been acute. But it's always better just to go with the two smaller angles first. That way you're guaranteed that you don't have to worry about the calculator not giving you the right one. All right, so that's the law of cosines. I think a little bit of practice on that and you'll be just fine. That finishes up unit 5 here. Unit 6, when we come back for our next set of videos, will be a set of videos, 3 videos long. We will be talking about conic sections.